I'll show the English version of the question first. Pause and try your best.
Now I'll show the Korean version of the question. Pause and try your best. To avoid any confusion, we'll approach this problem in sequences. We've been given a function gx in terms of fx. On differentiating with respect to x, we know that for local extrema, x has to be equal to alpha. Thus, the following expression has to be equal to 0. However, for this expression to be 0, either f alpha is equal to 0 or cos f alpha is equal to 0. We need to keep these results in mind for later. Let's consider fx to be a 3-degree polynomial with coefficients 6 pi, p, q, and constant r. Also, it was mentioned in the question that alpha 1 is equal to 0 and g0 is equal to 2 by 5. And so, we get this equation. Now, f0 is just constant r. On solving further, we get r equal to pi by 6. Also, remember this? F alpha is equal to 0. We could say that any one of these possible values would be valid for f dash alpha equal to 0. Let's say f dash alpha 1 is equal to 0. Since alpha 1 is 0, we get q equals 0, which means fx is. Now we only have coefficient p to solve. Remember about cos f alpha equals 0? From this, we get f alpha equals plus minus pi by 2, or plus minus 3 pi by 2, or plus minus 5 pi by 2, and so on. If it's easy to understand so far, consider subscribing since it helps the channel out. To proceed further in the question, it is necessary to analyze function fx. If we look at its derivative, we notice that the discriminant is greater than 0, which means it has 2 real and distinct roots. By Rawls' theorem, we can say that fx can have at most 3 real roots. Furthermore, its critical points are 0, which is alpha 1, and minus p by 9 pi. Also, it is mentioned that alpha is greater or equal to 0. In other words, it's positive, and the consecutive values of alpha are in ascending order. Let's sketch a rough graph of fx. We need to decide if the function will have a local maxima or minima at x equal to alpha. One of its roots must be in the negative x-axis, so the other 2 roots has to be in the positive axis for f to have 3 roots. So, it's not this one. Neither is it this. However, this graph perfectly fits the conditions. We'll need this for later. Coming to the second part of the question, solving and simplifying, we get this equation. Now, our job is to find the value of f alpha 5 and f alpha 2, so it satisfies the equation. F alpha can be any of these values. That must mean that the critical point by 9 pi can either be alpha 2 or alpha 5. Now, this gives rise to 2 cases. Either alpha 2 is the critical point, or alpha 5 is the critical point. Case 1, where alpha 2 is the critical point. We get to see that the value of f alpha 2 lies between the range as shown, which means alpha 5 must be 5 pi by 2. Now, checking if it satisfies the equation. Seems like it doesn't. F alpha 2 cannot be pi by 6. Thus, this case is invalid. Moving on to case 2, where alpha 5 is the critical point. Here we get to see that f alpha 5 lies within the range as shown. Which means that f alpha 2 must be minus pi by 2. Now, checking if it satisfies the equation. Seems like minus 17 pi by 2 satisfies the equation within the given range. From the analysis of fx and the two cases, we get f alpha 5 equal to minus 17 pi by 2 and alpha 5 as the critical point, minus p by 9 pi. We can substitute the value of alpha 5 in fx. On solving, we get p equal to minus 9 pi. Hence, fx is, and its derivative. Now, we need to find the value of g dash minus half, which on solving we get. Comparing with a pi, we see that a is equal to 3 root 3. Hence, a square is equal to 27. Thanks for watching. Don't forget to subscribe.